You know that feeling, right? You pop open your laptop, click on a Wi-Fi network, and bam, you're online. It feels instantaneous, almost like magic. But it's not magic at all. It's actually this incredible, invisible dance of technology happening behind the scenes. And today, we're going to pull back that curtain and show you exactly how your computer actually gets online.
So let's really think about it. You click connect. What actually happens in those next 3 seconds? I mean, before you can even move your mouse over to your web browser, a whole conversation has already taken place. Your computer has basically walked into a new place, introduced itself, got a temporary address, and even received a map to find all the popular spots like Google or Netflix. How on earth does all of that happen so fast? Well, that's exactly what we're here to figure out.
You know, to really get why this is so amazing, let's just imagine for a second what the world would be like without this automation. Picture you're the IT person for a big office, 100 computers, and you have to set up every single one by hand. You'd have to walk to each desk and manually type in its unique IP address, that's like its street number, the subnet mask, which is kind of like its zip code, and the gateway, the main road out of the neighborhood. Make one tiny typo, it won't work. Even worse, what if you accidentally give 2 computers the same address? Now neither of them can get online properly. It would be a total, complete nightmare.
Okay, so to save us from that manual configuration nightmare, engineers came up with our first unsung hero of the internet, a little something called DHCP. Honestly, the best way to think of it is as the network's official welcome wagon. It's this super efficient, super friendly service whose entire job is to do all that boring setup work for you. And it does it instantly and perfectly every single time.
Now, the full fancy name is Dynamic Host Configuration Protocol, which, yeah, is a mouthful, but it really does exactly what it says on the tin. It's a protocol that dynamically configures your device. It's the service on the network that just hands out all the crucial information your computer needs to get started. We're talking about that unique IP address, the street number, the subnet mask, the neighborhood, and the default gateway, that all-important exit ramp to the rest of the internet. It's the whole package delivered automatically.
I absolutely love this analogy right here. If the entire network is a city, then the DHCP server is basically City Hall. When your new device shows up, it doesn't just wander around and pick a random house to live in. No way. It walks right into City Hall and says, "Hey, I'm new in town, I need an address." And DHCP looks at its master list of available addresses, hands one out, and jots down, "Okay, this laptop has this address for the next 24 hours. This is so crucial because it makes sure no 2 devices ever try to claim the same spot, which would cause a total traffic jam. And what's cool is that this isn't just the server barking orders. It's actually a very quick, very polite, 4-step conversation. It all starts with your computer, which at this point has no idea where it is. It basically sends out a broadcast to the whole network, just shouting into the void. Then the DHCP server hears it and makes an offer. Your computer says, "Yep, I'll take it." And finally, the server sends back a confirmation with all the details. Let's break down exactly what's being said in this little chat.
This whole back and forth is known as the DORA process. D-O-R-A. First comes discover. Your computer shouts out to everyone, "Hey, is there a DHCP server around here?" Then comes the offer. A DHCP server pipes up and says, "Yep, I'm over here. How about you use this IP address?" After that, your computer sends out a request, basically telling everyone, "Awesome, I'll take the one that server offered me." And finally, the server gives the acknowledge, making it official. It's all yours, welcome to the network. And the craziest part? This entire conversation happens in less time than it takes to blink.
All right, so mission accomplished, right? Our computer has an address. It's officially on the map. But wait a minute, there's another problem. We don't go around memorizing long strings of numbers to get to websites, do we? Of course not. We use names, like Google.com. So how in the world does your computer translate a simple name that we can remember into the complex numerical address that it needs to actually find the server? Well, that brings us to our next hero, DNS.
And this really shows you the problem right here. On one side, you have what we humans understand, simple, memorable names. On the other side, you have what computers need, precise, numerical IP addresses. They're speaking 2 totally different languages. So we need a translator. And that translator is the Domain Name System, or DNS. The absolute best way to think about DNS is as the internet's giant global phone book. It's that simple. When you type in a website's name, your computer just uses DNS to look it up and find the correct number, the IP address. It's exactly like looking up a friend's name in your contacts to find their phone number. But here's the thing. This isn't just any old phone book.
It's so unbelievably massive that no single server could possibly hold all the information. So your computer has to go on a little detective quest to find the number it's looking for. It starts by asking its local server for help. If that server doesn't know the answer, it has to start asking for directions, moving up a chain of command from server to server until it finds the one that has the definitive answer. Let's trace that journey.
Okay, here's how the detective story plays out. First, your computer asks its local DNS server. Think of this as the local library. If the librarian hasn't heard of that website before, they have to go higher up. They ask a root server, one of the big bosses of the internet. The root server says, I don't know the full address, but I know who's in charge of all the .com websites. Go talk to them. So the request goes to the top-level domain, or TLD server. That server says, oh yeah, I know who owns google.com. Here's the address for their server. And finally, the request gets to the authoritative name server, the one that holds the actual official record. It gives the IP address, the answer is sent all the way back down the line, and your local server hands it to you. And, this is clever, it saves a copy, so the next time you ask, it knows the answer instantly.
So if we could actually peek inside one of those authoritative servers, this is kind of what it would look like. It's just a simple database of records. You've got A records, which are the most common type. They map a name to a classic IPv4 address, the kind of internet address we've been using for decades. But we're actually running out of those. So now you also see a lot of AAA records, Quad A records, which point to the newer, much longer IPv6 addresses. There are way more of those to go around.
Okay, so we've got an address automatically, thanks to DHCP, and we can translate names into numbers, thanks to DNS. We're doing pretty well. But what happens when you're on a huge network? Think about a university campus or a massive corporate office. How do you keep all of that traffic organized and, more importantly, secure? That's where our last two key players come in. VLANs for keeping things tidy, and VPNs for keeping things safe. So let's start with VLANs, which stands for Virtual LAN. It's a really clever trick. It lets you take one big physical network and slice it up into smaller, totally separate virtual networks. The best way to picture it is a single, huge office building. A VLAN is like putting up invisible digital walls that create separate departments. So you have accounting over here, sales over there, and engineering in another corner. Even if they're all plugged into the same physical equipment, the traffic from the sales department can't just wander over into the engineering department's network. It's blocked, unless you specifically set up a doorway through a router. This is awesome for performance, and it's a huge boost for security.
And this isn't just some abstract idea, it's done with really simple code. You're basically just telling a network switch, hey, listen up, anyone plugged into ports 5 through 8, they're on team 100. And anyone in ports 9 through 12, they're on team 200. So now, a computer plugged into port 7 is completely digitally walled off from a computer in port 10, even though they're connected to the very same physical box. Pretty cool, right?
Okay, last piece of the puzzle, security. Specifically, what happens when you're not in the office? What if you're at a coffee shop using their public Wi-Fi? That's where the Virtual Private Network, or VPN, comes in. And the analogy here is just perfect. Think of a VPN as your own private armored subway tunnel that runs deep underneath the busy public streets. When you turn on your VPN, you're not using the public internet where anyone can potentially peek at your traffic. Instead, you step into the secure, encrypted tunnel that takes you directly and safely to your destination. It shields everything you do from prying eyes.
And from your side, it's super simple. First, you open your VPN app, and it makes a connection to a special server. Second, that server checks your username and password to make sure you're actually allowed in. And once it verifies it's you, boom, it builds that private, encrypted tunnel just for your computer. Finally, you're in. All your internet traffic now goes through that secure tunnel, straight to your office network. You can get to all your files and work stuff just like you were sitting right there at your desk.
So there you have it. Let's wrap this all up. From that single click of the connect button, you have all these amazing invisible systems working together in perfect harmony to get you online quickly and safely. They really are the unsung heroes of our modern world.
So, the next time you get online, just take a second to remember that hidden dance. First, DHCP acts as the friendly greeter, automatically giving you your network address. Then, DNS works as your personal interpreter, translating the website names you type into the numbers computers need. If you're on a big network, VLANs are the traffic cops, keeping everything organized and in its own lane. And if you're out and about, a VPN is your personal security detail, wrapping your data in a cloak of invisibility.
It's just incredible when you think about it. Every single click, every tap, is built on top of these layers and layers of brilliant engineering that just work, completely out of sight. It really makes you wonder, right?
What other invisible systems are out there quietly running our world? Thinking about that kind of stuff is what we're all about. Thanks for tuning in.